Okay, we're going to start talking about something called the standard normal distribution. The standard normal distribution, in some ways, you can look at it as being something which we don't necessarily need nearly as much as we used to need. Before calculators could work out values for any normal distribution, which we were seeing in the previous videos, where we can, for a normal distribution, we can put in any lower and upper, any sigma and mu. We had to use formula booklets for the normal distribution. Now, with binomial, you can do it for set n values, and you can do it for a range of the most likely p-values that you would get. However, for the normal distribution, there is, because it's a continuous distribution, mu and sigma can be anything. So you would need to just have like hundreds and hundreds of different values. But luckily, there is so much symmetry and so much kind of common shape to the normal distribution. There is actually something we can do, and that is we can create something called the standard normal distribution. So on the left-hand side here, this is an example. This is the standard normal distribution. It has a mu of 0 and a sigma of 1. On the right-hand side, here's just some random other normal distribution, which I have got as mu of 40 and sigma of 4. So we can see the middle of it is at 40 rather than 0. And it's wider because the standard deviation is 4 rather than 1. One thing you will note about these two things is because the area represents probability, the area under these graphs is the same. The area under this graph is 1. The area under this graph is also 1. By making sigma equal to 4, it's become wider and also shorter. I can change it to make the sigma 1, and you can see as I change that, it becomes, that's when it's 1, so it's now the same as on the left, and that's when it's 4. The area underneath is the same. Think of it like a balloon. So on the left-hand side is the standard normal distribution. On the right-hand side is a different normal distribution. Now the useful thing is we can actually move this distribution over to the standard normal one and squash it until it's the same. So this is going to be a trick we're going to use. So firstly, I translate it by taking away 40. Think of your graphical transformations. So I take away 40, and finally I'm going to divide by the standard deviation, and it's going to be squashed until it is the same. You can really think about that as the graphical transformations you're doing. A translation followed by a stretch. Translation followed by a stretch. So we can actually take normal distribution values and move them over there. So what have we got? Let's write this down. The standard normal distribution is, it's given a special letter actually. It's given a special letter of Z, and it is Z, and we reserve that letter Z just for the standard normal distribution. And it is the normal distribution with mu 0 and standard deviation 1. Quite commonly we put this 1 squared. Obviously we know that 1 squared is just 1, but again, the standard deviation is that. So we have got mu is equal to 0 and sigma is equal to 1. And this is the fundamental fact that makes this all possible. For any normal distribution, X is normally distributed with mu and sigma squared. This is any normal distribution, does not matter what normal distribution we've got. If I take X and I subtract from every value in that distribution mu, that's a translation by mu, and I divide by sigma, this becomes the standard normal distribution. So if I subtract mu and divide by sigma, it becomes the standard normal distribution. So I'm going to show you that too graphically again. It's exactly what I said. Subtract mu, now it's got the correct mean, divide by sigma, Now it's got the right sigma, and it becomes the standard normal distribution. So in the past, before we had a calculator that could do it for any mu and sigma, we had a table of the standard normal distribution, and every other distribution had to be made into the standard normal distribution so that we could calculate values. You don't have to do that now because the calculator can do it. But that is something called the standard normal distribution. However, you might be thinking, okay, so what's the point of even doing it? Well, there is actually a kind of question which we need the standard normal distribution. And that is if we don't know what mu or sigma is. If we don't know what mu or sigma is, well, we can't type it into the calculator. So we need this to be able to work in that kind of situation. So here we go. I've got a question here. I've got a normal distribution. I don't know what mu is. I do know, though, that the probability of x is less than 2 is 0.1745. I don't know what mu is. There's nothing I can do in the calculator here. There's nothing I can write into the calculator. I don't know what mu is. The inverse normal is not going to work because that's if I know the probability but don't know the value here. So just what can I do? So I have to use the standard normal distribution. I'm going to need to use this fact that x minus mu divided by sigma is equal to the standard normal distribution. Or actually, this is going to have a normal distribution of 0, 1 squared. So this is what I'm going to do. I'm going to start with this fact, and I'm going to write this. I'm going to write the probability of x is less than 2, I'm deliberately leaving a bit of gap, is equal to 0.1745. And now I'm going to use this fact, and inside the brackets, I'm going to change it to make it become the standard normal distribution. So I'm going to write the probability of x minus mu, which I don't know, divided by sigma, which I do know, is 3, is less than 2 minus mu, because it's an inequality, I have to do the same to both sides, divided by sigma. Note that it doesn't matter that I'm dividing on both sides of an inequality. I'm not going to have to change the direction of the inequality because, well, sigma is always going to be a positive value because it's a measure of spread. And this is going to stay the same on the other side, because all I've done is changed the inequality in exactly the same way that I could have times this both by 2 and said 2x is less than 4. I've just taken away mu and divided both sides by 3. Now this here becomes z. So this here is the standard normal distribution because of this fact that I was just using. So I can actually write that the probability of z being less than 2 minus mu over 3 is equal to 0.1745. Okay, so that all seems good, but you may be still asking what is the kind of the point in this, and this is where the point comes in. Because if you now look at what we've got, I've got the probability of a normal distribution that I know being less than something is 0.1745. So up here, I didn't know what x was, but here I do know what z is. Z is normally distributed 0, 1 squared. So this value here I can find using the inverse normal, because I now have it in terms of a distribution which I know, whereas before I didn't. So I can do it. I can use the inverse normal as such. So I go to the inverse normal distribution. The area I want is 0.1745. My sigma is now 1 because I've scaled it so that it's the standard normal distribution. And my mu is 0, again, because I've scaled it to be the standard normal distribution. And I can see that it is minus 0.9365. minus 0.9365. Minus 0.9365. Now, I'm going to look at the last two lines that I've written. I'm going to look at these two lines. And I spot that it's the same on the right-hand side. It's the same here. So therefore, this and this must be the same, because that everything must be equal. This is the same. This is the same. So this is the same. So 2 minus mu divided by 3 must be equal to minus 0.9365. And I've created an equation with only one unknown, so I can solve to find what mu is. Feels a bit funny, but essentially what we did is we've made it into a question that we can use the calculator for. So to finish off, I'm going to say 2 minus mu is equal to 3 times minus 0.9365. Add mu to both sides, subtract, and we will see that we get mu is equal to, with a bit of thought, 2 plus 3 times 0.9365. Note that I did minus a minus there at one point. We're going to be clever with our calculator. I'm going to store this value, store as A. I'm going to go back to the start, and I'm going to say 2 plus 3A. And I get minus 0.08096. 8096. I think I made a mistake in yesterday's. Minus 0.8096. So that would be our value of mu. It's a bit of a funny value. It seems wrong. That doesn't seem right. Oh, no, I have made a mistake. My A value is negative, isn't it? And I've done it. So actually, I need to, that is wrong. So let's correct it. It should be 2 minus 3A with a bit of thought. Hopefully see that. That's more like it. That's more like it. 4.80810. 4.810 or 4.81. 4.81. So yes, I could have easily seen that that was a pretty ridiculous thing to write. 4.81. 4.81. Okay, and that is my mu value. So I've finished that question. Okay, so this example, what we did, to recap, is I wrote the probability out. I used the fact that if I take away mu and divide by sigma, it becomes a standard normal distribution. I found the standard normal distribution value using the calculator. I compared things that were all the same and solved the equation that I ended up with. So there's one other kind of question that comes up on this, and that is if you knew neither mu nor the standard deviation. If you knew neither, we've got a bit more to do. So in this question, we're going to find both mu and sigma. Probably going to not quite finish this question off, but I'm going to definitely give it a start. It works in a very similar way. So we've got the heights of a population of women, and we're told that they're normally distributed, and there's mu and sigma. And we're told two facts. So I'm going to immediately try and change what's written on the screen into mathematical notation. Always a good way to start these questions. So X, I'm going to call the heights of population of women. So I'm going to say X represents heights of women in this case. And X has mu and sigma squared. And I need to very carefully write down the two facts that I've got. I've got that the probability of X being greater than 172 is equal to 0.3. And I've got that the probability of X being less than 154 is equal to 0.05. Now you'll note I know neither mu nor sigma, but I've been given two pieces of information. So I don't know either mu nor sigma, but I've got two pieces of information. And that should hopefully feel a bit like a simultaneous equation to you. So I'm going to do exactly the same as I did in the last one, but I'm going to do it on both of them, end up with a simultaneous equation, and solve. So I'm going to use again that, and I'm going to write at the top here to remind myself, x minus mu divided by sigma is equal to z, the standard normal distribution. So let's change the left-hand side. And I'm going to get, and you can, once you're comfortable, I did a step in between here, but you can skip straight to saying, in which case, z, I'm actually going to do it firstly. I'm going to change it to a less than. I know that my inverse normal gives me a less than, so I'm going to first change this immediately into x is less than 172 is equal to 0.7. So if greater is 0.3, less than is 0.7. And I'm going to just rewrite this. So I think it is important to kind of set ourselves up with less thans because of the fact that the calculator only does that for the inverse normal. And now I'm going to make my shift to z. So to z, it will be 172 minus mu divided by sigma. Z is x minus mu over sigma, so I've just let that be that. This is 0.7. And on this side, I get z is less than 154 minus mu over sigma. And this is equal to 0.05. Okay, I need a bit more gap. Okay. So I now need to find my z values that are going to be required for here. 0.7, leave that the same. Here, z is less than something is going to be 0.05. And if I can find this number over here and the other number, then I can make it work. So I need to go into my standard normal distribution. My inverse normal, I've already got it set up with sigma is 1 and mu is 0. Very easy to accidentally put them the wrong way around. Having sigma of 0 will cause you a problem, but just be really careful about it. 0.7 here gives me 0.5244. I am going to store that as A. 0.5244. So 0.5244. And going back and putting 0.05 here. Minus 1.6449. Minus 1.6449. Minus 1.6449. And now you will hopefully see that I have got a situation where this must be equal to this, and this must be equal to this. So overall, I have 172 minus mu divided by sigma is equal to 0.5244. 154 minus mu over sigma is equal to minus 1.6449. This is now just simply a simultaneous equation that we're going to solve in the same way that you would solve any simultaneous equations, and we'll end up with mu and sigma. However, it's probably a good point to kind of be as clever as possible with a calculator. So what I'm going to do is I'm going to rearrange this as such. This will be 172 is equal to 0.5244. It might be worth me reminding myself that I stored that as A in the calculator. Sigma, and then add mu, and I'll get plus mu here. And this side is 154 is equal to minus 1.6449 sigma, add mu. That is a simultaneous equation. It's a linear one. I can use the calculator to solve it for me to save time. So I'm going to go into my solving simultaneous equation in the calculator. It's a simultaneous equation. I've got two unknowns. and I want to put as my sigma is going to be my x and my mu is going to be my y. I stored 0.5244 as a, so I can actually directly put a in there. And I can put 1 there and 172 here. And that is b there. It's nice that it kind of shows me that I've definitely got it. Oh, did I never store it as b? I'm just going to type it in. It'll be close enough. 1.6449. Could have been slightly better, but that's not the end of the world. That's 1, and that is 154. And then I press equals, and it gives me my x value of that, which is going to be my sigma, 8.30. So write that down. Sigma is 8.30. And back to my calculator. And my mu is 167.6. 167.6. Mu is equal to 167.6. And that is my mu and sigma. It's worth just taking a second here to check, do these answers vaguely make sense in the context of a question? So I've got an average of 167. So about 30% are above 172, 5% between less than 154. Does 167 as a height make sense? Yeah, I think it does. Sigma, remember 2 standard deviations from the mean should be 5%. So 2 standard deviations from the mean. So if I take away 16 or so from, is that about right? Yeah, that feels about right. So we're kind of roughly in the right kind of region for those values. This is I've kind of talked through the standard normal distribution, and then I've covered some examples. These can be quite tricky. So kind of carefully go through some examples and follow what I wrote there. I'm going to put some suggested exam questions here, suggested textbook questions. So I recommend you can do some exercise 3D if you like, but I would say that's optional because the real thing that you've got to be practicing is exercise 3E. Exercise 3E is really important to practice, and that I'm recommending questions 1, 4, and 5, and then after that, for some slightly harder questions, some exam style questions of 12 to 14.